Good afternoon, ladies and gentlemen. It's an honor to be here, and I thank the Prize Committee for giving us an opportunity to present our work in this forum. I'm going to spend the next half an hour speaking on our work on marketing optimization in the retail banking context. My name is Ram Susundararajan, and I'm part of the global research organization of the General Electric Company. This work was done in collaboration with Bank BPH, GE Capital Group Poland. The entity was formerly known as GE Money Bank Poland during the time when this work was done, which is in the period 2003 to 2009. The outline of this presentation is as follows. I will spend some time motivating this work and providing an idea of the business context, and then providing an outline of the solution itself. And once the skeleton has been built, I shall flesh out the details and focus on some areas where we feel that we have done some work in terms of contribution to the ORMS practice beyond application of standard techniques to a problem. Now imagine you're running a bank. You have a bunch of customers, you have a bunch of products that you want to offer them. How are you going to do it and make a lot of money in the process? Retail banks typically approach this problem from multiple standpoints, and all of these usually work at the same time. One is a product perspective. There are various product lines. Each product has a number of parameters that need to be controlled. So for instance, if you're managing the credit card product, you need to manage credit lines, you need to manage the interest rates, you need to manage fees, and so on and so forth. Another is a functional perspective. So you may have sales and marketing divisions, pricing divisions, risk divisions, and all of these have to work in concert, both at a product level and at an overall bank level, in order to make the business run. A third perspective, which is reasonably popular among banks, is a customer perspective. And CRM has become reasonably popular in recent times because it is more expensive to acquire a customer than to retain one, which means the challenge is you have to identify and retain the most profitable customers that you could have. Now, how do you do this? One very big part of CRM processes is to sell new products to the customer so the customer remains on your books and keeps borrowing money from you and keeps paying it back to you. And this is the part of the process that we're going to concentrate on in our presentation today, cross-selling. The problem of cross-selling is that of identifying which customer to target, how to target the customer, what product to offer to this customer, and at what terms. Our specific focus has been on the identification of a customer, the identification of the product to offer to the customer, and the channel through which the offer is conveyed to the customer. Let me spend some time giving you an idea of the business context itself. GE Money Bank Poland is an entity that acquired its customers primarily through sales finance loans. So imagine that there is a fellow who walks into a high-end electronics store and decides to buy a television. GE helps him finance that purchase through a sales finance loan. So it's now got a customer on its books. The trouble is that once the loan gets over, the relationship gets over unless you're able to sell something else. So how do you figure out what to sell? That's essentially the question. Now GE has a variety of products that it could offer to the customer, but the ones we were focusing on in our work was primarily two products. One is the sales finance loan again, the other is a simple personal cash loan. Now consider the question of cross-selling for a moment. How do you decide what to offer to a customer or which customer to offer it to? The most basic way of doing this thing is to say, I'm going to offer money to people who are going to give it back to me. And there are a whole bunch of bankers sitting out there who are probably shaking their head ruefully at the very thought of doing this. Right? A second level would be to say, I'm going to offer money to people who are likely to take it and give it back to me. Why would you do this? Because you have a limited amount of money to spend on marketing campaigns where you target new customers. So you don't want to target every Tom, Dick and Harry, you just want to target those people who are likely to take it from you. A third level of analysis could be to say, I'm going to offer money to people who are likely to take it, likely to take a lot of it and give it back to me. That is profit-based. Now, intuitive as this may seem, and there is actually published literature that does talk about profitability-based cross-selling, in practice, very few retail banks do this. More often than not, they either just look at risk and then do carpet bombing beyond that point, or they look at just risk and response. Risk, response, and profit are not often seen. Now, it might seem that as you add more and more criteria to determine who a good customer is for cross-selling, you're actually reducing your available customer base for making new offers. This is not exactly true in real life because, like I mentioned, cross-selling does not exist in isolation. It exists in an ecosystem that is also inhabited by product management initiatives and functional initiatives. So supposing a product line manager has certain asset growth targets to meet, those cannot be met if the cross-selling process is too stringent in identifying customers to make offers to. And at the same time, if you did not have control on the portfolio size, then both risk and wasteful marketing expenditure would adversely affect your bottom line. So the objective is not to just narrow down to a very small group of very desirable customers who are profitable, responsive, and riskless, but rather to understand the trade-off between all of these factors. And then find the optimal operating point and decide on which customer to offer which product to and through which channel. Now the solution for this problem is motivated by this business context, which means that it starts developing from the point where we decide what business impact we want to achieve, and every step in the process is built from that point backwards, although the process itself is followed onwards. So you start off with the business impact. What do you want to do? You want to make a lot of money. So you want to increase net income from a campaign. And by net income, I mean the bottom line. That includes both whatever revenue you get, minus risk and marketing expenditure and any other operating costs that you might have. How do you do this? You pick the right customers, which is your decision problem. How do you pick the right customers? That presupposes that you have some idea of what the payoff would be for every decision that you could make at a customer level. So if you were to offer product A to the customer, is he likely to take it? Is he likely to take a lot of money? And is he likely to give it back to you? So these are estimates that you want to put into place and then use them to build your decision model. So that's where predictive modeling comes in. And how do you build these predictive models? You build them by using historical data. You take past offers that you've made to your customers, you see what their response has been, you see what you knew about the customer before you made your offer, correlate that information with the response characteristics, build your predictive models, put them into a decision model, get your output, and there you have your business impact. Fairly straightforward when you think about it at a broad process perspective, except there are a few challenges. One is, businesses evolve, business environments evolve, business strategies evolve. None of these are static, which means that your solution cannot be static either. At a very simplistic level, this could just mean that you keep updating your models as and when your data changes. But at a more complex level, it could mean that you have to have a process that's robust enough to deal with more drastic and sudden changes. For instance, in the specific case that we're dealing with, there was a fairly drastic change in 2006 when an interest rate cap legislation was introduced. This meant that any data you had prior to that involved giving loans at interest rates that were much higher than the ones that you could give later. So that was a fairly drastic change that the model had to be robust enough to deal with. Another aspect is the fact that it needs to exist in an ecosystem inhabited by other processes. And these could impose certain constraints on this one. For instance, IT systems and regulatory requirements may mean that there are only certain kinds of information that you could get about a customer. The existence or non-existence of a credit bureau could mean a difference between what kind of information you would get about the customer's indebtedness to other financial institutions. Now, all of these impact the kind of models you can build and therefore the kind of decision systems that you can make on the basis of these models. The less data you have, the worse your predictive models are. And the worse your predictive models, the worse your decisions. So the challenge becomes, can I make good decisions with models that aren't as good as I like? Availability of information, apart from these, could also impact the way in which your decision models themselves are built. Certain factors relating to constraints in your optimization problem may not be available at the right time. So how do you deal with that? The last and most important fact is the following, that this solution lives in a business and has to be implemented and maintained by the analysts in that business. At one level, it implies the necessity to train these analysts so that they understand both the process and the techniques involved and the boundaries of the solution so that they know when it's working well, when it's not, and when it's time to make an update. At another level, it also means that you cannot design a solution that's too complex to tweak. So all of these challenges imply the necessity to design something and deploy something that's sustainable and works in a changing environment. And these are the challenges that we have tried to deal with in our solution. Let me give you an overview of the process itself. This is more or less a reiteration of what we spoke of, except that I shall concentrate on a couple of specific aspects. Steps 1 through 4 involve collecting historical data and building predictive models using the same. Step 1 is where you measure customer level inputs prior to a campaign that was run in the past. So before an offer is made, you figure out what you know about the customer. This could include socio-demographics. It could include account level information in terms of what products the customer holds. It could include behavioral information in terms of how the customer has repaid his past obligations. And all of these give you some picture of what the customer was like when you made the offer. Now you measure response to various CRM stimuli in terms of what kind of products you offer to these customers and which channels you used. Certain aspects of response are fairly simple to measure. The response event itself is binary. It's straightforward. What kind of loan the customer took, what volume he took, what term, what interest rate, these are straightforward as well. What is complicated, where the wrinkle creeps in, is when you want to measure risk. Technically, a customer could default on a loan that he's taken any time from the beginning of the loan to the end of the loan. So technically, if you have to measure risk accurately, you're going to have to wait until the end of the loan. But that means that if you're offering loans that are about of 3 years duration, you're going to have to wait for 3 years and a bit before you have enough data on risk to build models. The trouble is, now your models are outdated. At the same time, if you decide not to measure risk and just go with volume, term, interest rates, and so on, you're living in a riskless utopia that real banks cannot function in. So how do you find a middle ground? You can't measure too early, and you can't measure too late. So how do you figure out where to measure risk? That is one of the challenges that we dealt with. Now once you've measured profit in some form, once this challenge has been dealt with, you have the question of building predictive models and you have the question of using decision models. So our technical contributions from an ORMS standpoint have occurred in 2 areas. One is in terms of using genetic algorithms for model building to predict customer response and a few other characteristics. The other is to use OR models for decision making once these estimates are known and a new campaign needs to be planned. And we shall speak of both the necessity for using these techniques as well as the way in which they were used in future slides. Let me just summarize a few points about the deployment and the results before I go on to the details of the solution. The solution was deployed in a phased manner, wherein each phase involved certain components being put in place, and as they gained more credibility, further components came in, and there was a certain process that was employed in how these were deployed, and we shall speak of that later. Another aspect is that the solution itself evolved, which meant that certain components, even though they were in place, were improved over time, both in minor and major ways. The third is there was a regular discipline of technology transfer, which helped the analysts understand how well this solution worked. Now let me spend some time discussing the details of the solution that we have built. As mentioned earlier, there are 4 aspects to this. The first is measuring value of past relationships, or in some sense, using historical data, collecting historical data, building predictive models, using these predictive models to make decisions, and then deploying them in a business context and assessing how much impact there has been. And we shall go into some of this in more detail. Let's look at the question of profit a little more. Profit has 2 parts. One is return, the other is risk. And return is essentially just an algebraic sum of inflows and outflows. Reasonably straightforward. The wrinkle comes in the form of measuring risk, as mentioned earlier. So we have a formula that is essentially a contributed value quantity, which is simply inflows minus outflows, minus a risk adjustment factor that we refine as rho times max loss, where max loss is essentially the maximum loss that you could incur on a loan, which is what happens if a customer simply takes the money and runs. Rho is simply a quantity between 0 and 1 that represents the fraction of the maximum loss that is actually incurred. As I mentioned earlier, time is a critical aspect. You can't measure too early, you can't measure too late. So a middle ground would be to measure at some point during the term of the loan. So imagine that you're observing the loan for about a year. At the end of this year, one of many things could have happened. Either the loan could have been completely paid off, in which case there's no risk, or the loan could have been completely written off, in which case you know exactly how much risk you incurred and what losses you incurred, or the loan could be active, in which case you have to figure out now what's the likelihood that this loan will now go into default and how much money am I likely to use. So in order to deal with the third case, we build Markov models in the following manner. An active loan can be characterized in the form of a certain number of states, the state being defined in terms of delinquency, outstanding balance, and so on. Now, loans can transition between these states over time. And there are 2 absorbing states that can eventually transition to. One is being that the loan is paid off, the other is that the loan needs to be written off. And there are fairly simple mathematical methods to figure out the probability that a loan that is currently in some state I would eventually transition into either default or paid off. And once that probability is known, that can be combined with the features of what is outstanding on the loan to arrive at the rho. Once you do that, your risk adjustment factor is obtained, and therefore you have a model. And this one works reasonably well if you know that a good number of your loans, wherever you do see default, you see it within a certain period in time. So let's say you see most of your defaults in a 12 to 18 month period. You set your observation window at 18 months. For the most part, you would have measured actual risk, and in the few cases where you're estimating risk of active loans using a Markov model, you're still reasonably accurate. And that way, you have a reasonably viable method of measuring profit. Now, once you've measured profit and you've measured response and default and so on and so forth, how are you now going to build predictive models? More or less straightforward. You're dealing with continuous quantities and you're dealing with some discrete quantities and you want to build models. Certain constraints. One is that the models need to be reasonably simple in their functional forms. Why? Because analysts need to be able to interpret these models and corroborate them against business knowledge and make sure that what they've learned is intuitive and not something that is an artifact of the current data. So one needs to build reasonably simple models. At the same time, these need to be robust models. Another aspect here that is of importance is the idea of building models for components of profit rather than the overall profit quantity itself. Now, why do we do that? A big aspect is flexibility and robustness to change. The idea is things change in the environment, as I said. So supposing that the interest rate regime changes, none of your historical data is viable anymore if you're just trying to model profit. On the other hand, if you're trying to model profit as a function of a set of components, and a lot of those components are still applicable and only some of them have to change according to the environment or according to changes in the business strategy, your models are still more or less okay. And you will still be able to get viable estimates that you can now use for decision making. One of the things that we did was to try and explore whether there was power to use what-if scenarios analysis while using a component model like this. Consider the question of credit limits. If you had a pre-approved limit that you were offering along with your loan offers, if you increase that pre-approved limit, what happens? With some customers, there could be an increased volume uptake and therefore increased revenue, increased profit. With a few of those, they might bite off more than they can chew, which means that you actually have increased risk and therefore decreased profit. So building component models and trying to understand the dynamics of risk versus return in case of certain variables being changed, certain off-of parameters being changed, allow us with a lot more flexibility in decision making than a simple profit prediction would give us. For building models themselves, we tried to use genetic algorithms. Why did we do this? These are simple linear models, but why use genetic algorithms? One objective is that we wish to tie in the model building very tightly to the decision making to the extent possible. Consider a situation where you just wanted to use a response-based targeting method and you had a budget to target about 20% of your customer base. A normal logistic regression model will maximize a likelihood function. What you need, however, is probably a model that if you were to use to generate response scores and rank these scores, would capture most of your potential respondents in the top 20% of the scores, because that's what your budget allows you. So your best model for that decision problem is a model that's able to achieve that objective, not necessarily maximum likelihood. Genetic algorithms as a method, since it's a direct search algorithm, allows you to define any objective as complex as you wish, and they don't need to be mathematically very well behaved. And that allows you with a lot of flexibility in terms of the kind of models you build. And since these objectives may change over time, the algorithm itself can remain constant. All you need to do is go in and change the objective depending upon your business necessity, and you still get reasonably good models. Second is that there is a need of rebuilding models and improving models over time, because this is an evolutionary method. You could start with an existing model and try and evolve from there to a better model. Another aspect of interest is how well you can generalize. So you build a model based on historical data. You have to apply it in a new campaign. A big problem, as I mentioned earlier, is that the business environment itself changes. Can you build models that are reasonably robust? So these are the challenges that we faced while building models, and genetic algorithms were used in order to answer a good bit of them. So the general process of building models using GAs involves deciding on a business objective, which essentially provides your fitness function, and then starting off with an initial population of models, each model essentially being just a set of coefficients. So you have a set of candidate models, and you evolve from that set of candidate models to better and better models over a series of generations through certain genetic operators. The genetic operators being one, selection, which is survival of the fittest models. Second is crossover, where characteristic of good models are essentially taken to produce new models. Third is mutation, where certain coefficients of some models are changed randomly to explore new areas of the model space to figure out whether there are good models existing elsewhere apart from where the population is currently. And the fourth is elitism, which is preserving the best models seen so far across generations. And through this process, we evolve from good models to better models across generations, and then arrive at a reasonably good set of models that satisfy our business objectives satisfactorily. One of the things we did in order to improve this process as far as generalization ability was concerned, especially in view of dealing with a changing environment, was to change the elitism step. The way we did that was as follows. You take your data set that you have to build your models and you divide it into two parts. One part is your historical data that contains as many examples as possible. The other is a validation sample that contains the most relevant data set you have. The reason you do this is because model builders who need to work in a changing environment face an analog of the bias variance dilemma. The most relevant data set may be very small, so your model is relevant but brittle. The available data set may be large, which means that your model is robust but not necessarily the most relevant. So in order to deal with this, we modify the elitism step in genetic algorithms by having two data sets. One is your training data set, the other is a validation data set that's most relevant. Over time, the elite set is maintained on the basis of training sample performance, but every few generations it is augmented on the basis of validation sample performance. So in some sense, you're learning from a lot of data, but fine-tuning with a little relevant data set, and therefore arriving at better models that function well. And on some real and artificial data sets, we have empirically found that this method works better both than logistic regression and plain vanilla genetic algorithms on a variety of performance metrics, both standard and business defined. Once you have these predictive models in place, the question now becomes, how do you optimize your decisions? There are two major problems to solve. One is which customer to target with which product. The other is which channel to use to convey this offer. One of the things that was observed was that the most reliable channel to convey the offer in the first instance was direct mail, because not everybody had a telephone, not everybody could be reached. So when you first made the offer, you wanted to make it through direct mail. But there was a lot of flexibility in deciding how to follow up on the customer, and it was also found that using a good follow-up strategy improved response rates considerably. So now you have two problems. One is what product to offer to what customer. Second, how to follow up on this customer using the appropriate communication channel. Now we solve this problem in these two parts. We solve the product offer problem separately, we solve the channel problem separately. Now why did we do that? One big constraint was information availability. Channel capacities and budgets for follow-up campaigns were not known at the point when product offers were being made. So we had to solve the problem in a decentralized manner. Another big challenge is the question of estimate reliability. So not all estimates built from the predictive models are very reliable. This is not an industry that's renowned for good predictive models. So you're going to have to you're going to have to make good decisions, but with models that are not so great. So how do you do that? One of the things we observed was that at an individual level, your estimates are not so great, but at a group level, they're a little more robust. The way we used this insight was in two ways. One was that when we evaluate predictive models, we evaluate in terms of group level statistics. And we also try and understand at what level of granularity does the predictive capability break down. This gives us an idea of what level of granularity we could make good decisions at. The second is to make the formulation itself for groups of customers. So the product of a formulation was essentially a question of maximizing the net income from the campaign, which is essentially a quantity derived from expected profit through the offers, minus a set of costs, some of which are marketing costs in terms of making offers to a set of customers, the other are overheads in offering and servicing these products. The constraints involve dealing with a budget, so your mailer cost cannot exceed a given budget. And second, as mentioned earlier, there are product management imperatives that need to be taken into account. So there are asset growth targets that product line managers place on the process, and that also determine how many offers you need to make in order to meet those targets. The decision variable we used was the number of customers in each group to whom a product offer was made. So this number could either be 0, in which case nobody in the group got anything. This number could be equal to the number of people in the group, in which case everybody got the same offer. Or it could be some number in between, in which case we solved a subsidiary assignment problem for that group to decide who got the offer. The data, as explained earlier, involved predictive values for response, profit, and volume. The volume being the part that goes into asset growth targets, response and profit being what goes into the net income calculation. The other problem is the communication channel optimization problem, or rather what the follow-up channel should be. Here we found that profit did not change much on the basis of channel, but response rate did. So we now just target on maximizing response rate through follow-up on a campaign with the following constraints. One is the overall budget for the follow-up campaign needs to be met. The other is that the channel choice can be determined only by availability, which means if a customer doesn't have a phone or if you don't have his phone number, there's no point in alerting an SMS as a follow-up channel to him. The third is channel capacity constraints. So if a branch plans to call customers and offer them loans, then it can only offer it to certain customers near that branch, and it can only offer it to a certain number of customers, and all of that makes its way into how exactly that channel is used for a set of customers. The decision variable is which channel to use to follow up and which phase of follow up to do it, because follow up itself could be done in multiple phases in order to use capacity optimally. So once all of this is covered, we were also able to maximize response rates. One of the other things that we experimented with that I would wish to speak about is the question of how to deal with unreliable estimates. As mentioned earlier, group level estimates are more robust than individual estimates. But even then, we're still looking at expected values at a group level. We're not considering what the spread of the estimates are. Also, when product line managers provide us with asset growth targets, or when CRM managers provide us with budgets, these figures aren't necessarily sacrosanct. There could be a certain amount of variation around them. One way of understanding this variation is through sensitivity analysis. So you could say, what happens if I increase my budget 10% or 20%? And you might find that with an increase in 10%, you have a big jump in net income, whereas from 10% to 20%, you don't have so much. That gives you some leeway in the decision-making process. Another way of doing it, which we explored, was essentially to represent these numbers as fuzzy numbers. The expected profit out of a group was also represented as a fuzzy number. Expected volume from a group was also represented as a fuzzy number. Once we do that, the LP becomes a fuzzy LP. So you have a fuzzy integer linear program that you need to solve now, and we solve that by making a conversion from there to a multi-objective program and then doing some analysis. So this was one method that we explored as well as far as decision making was concerned. Now, how do we deploy all of this? Number of stages. One is a simple offline evaluation. You take historical data where you know what happened. You take an existing method that's currently employed by the business. You take the new method, you compare the two on a variety of metrics and see what works best. It is essentially the sort of method that one would apply in the first go. If that works well, then we have a second layer of analysis where we run a live pilot. So we take a subset of customers from an existing campaign, divide that into two groups. To one group you apply the existing process, to another group you apply the new process, and then you compare on a variety of metrics. There are three reasons why one would do this. One is to understand how well the method works on live data. The second is to understand whether there are implementation issues that need to be dealt with before rollout. The third is to have some idea of what the financial impact is. And the better we understand the impact, the better we will be able to assess where to go from here, and the better we will be able to build credibility for whatever is put in. Now, various parts of our solutions exist at various stages of this. And once this impact is assessed using a variety of ways, wherein you extrapolate appropriately from this subset to the whole campaign, you also compare this financial impact with the other qualitative costs in deploying a new solution that is, more often than not, a little more complex than whatever is already in place. So in some sense, you're looking at total revenue or total profit from a new process versus total cost, both qualitative and quantitative, of doing away with the old process and putting a new process in place. And once this is understood and it turns out favorably for whatever it is that you want to deploy, it is then rolled out to the entire customer base in the next campaign and becomes part of the standard process. Now, any improvement will have to consider this as the champion and will have to challenge it before it can be deployed. So there are various problems that we dealt with and various methods that we tried, including the use of neural networks for predictive models, support vector machines for predictive models, fuzzy optimization, credit line optimization, and so on, some of which made it to the finish line and got rolled out, some of which have attained various levels of offline and online evaluation. To give you some idea of what it is that we have been able to deploy, normal product offer optimization has been deployed in terms of a group level formulation. Fuzzy LP has been tested in an offline pilot. Credit line optimization, which is the problem of trying to figure out whether an increase in credit line increases just the revenue or also the risk unacceptably, was gotten to the stage of a live pilot. Genetic algorithms for product offer for predictive models have been deployed, and marketing channel optimization for follow-up campaigns has also been deployed. In terms of general benefit, there has been a benefit of over $20 million in incremental profit over existing processes to date, and this achieves a factor of over 20 to 1 vis-a-vis R&D costs and deployment costs. But the more important in our sense and the more gratifying part of the impact is the fact that OR became a part of the thought process out there. OR in general is a beautiful way of translating decision problems to optimization problems. And what was wonderful was that through a process of training and technology transfer, this was well understood by the client, and they understood not just how a particular method was used for a particular problem, but rather the possibilities of this method to solve a variety of problems. Our original brief was to solve product offer optimization. This got extended to deal with communication channel optimization and a bunch of other things because they understood its possibilities. I shall speak no more and let my client speak.
Hello, my name is Carolina Bong. I'm leading the analytical team in CRM department in BPH Bank GE Capital Group in Poland. I would like to tell you how the marketing optimization project help us add the value to CRM activities. The majority of financial institutions make their mailing decision and choose customers based on response models. Our approach was quite innovative, and we introduced 2 new steps in this process. As a result, we managed to make the optimum decision, and we achieved 2 things. We improved profit per campaign, which was the major goal and success from business perspective, and we learned how to use effectively statistical tool for advanced analysis to solve other CRM process issues in the smart way. We also learned how many more opportunities this method creates. For me, it was a unique experience to take part in this exciting project, and I look forward to use these new skills for the new challenges. Thank you.